Here we'll discuss frame relay. Frame relay is another encapsulation type like we've looked at in the past with HDLC and PPP. Now it's a little bit different in how we can control the topology and what the ISP is going to provide for us. Frame relay has been one of the most popular WAN services for the last couple of decades, and the big reason for this is money is always a factor, and frame relay is very cost effective. Frame relay is it's non-broadcast multi-access network, which means absolutely nothing on the network is going to broadcast. So not even routing protocols like RIP are going to be able to send broadcasts out. But we can still efficiently have multiple people accessing this and connected to it. It's a little bit more complex than a straight up leased line network, because in a leased line network, we have something like this, where it's one connection per router. So if we thought about the left-hand side being our corporate router, the right-hand side being branch routers, we would have one connection per router. Now this has advantages and disadvantages. One is obviously a cost being a huge disadvantage because we might have to trench multiple cables, or we might have to buy additional modules to plug into our routers to get them to support that many serial connections. If our router is full, maybe we need to buy additional routers just to have these different connections. It is advantageous in the sense that we have 3 points of failure, and each of those has its own dedicated bandwidth to it. What frame relay allows us to do is create these logical mappings. So we have the same topology here, but we're going through this mysterious frame relay cloud, which would be like our ISP. Through that cloud, our traffic will get tagged with what's called a DLCI, or a DELCI number, and we'll talk about those in a minute. And based on what those are, those will get transmitted and translated back into that single connection. So the router can pick apart what connections it should be actually looking at. This is an extremely similar concept to what you might have seen with VLANs. So if we did the router on a stick VLAN topology, or we're looking at tag traffic, really the same type of concept here. With frame relay, the ISP is typically going to sell us a committed information rate. This is something you might have seen when you've studied QoS. This is basically the rate that they're going to say, you are guaranteed this much bandwidth on each line, and maybe if there's extra resources, you can burst your traffic above that committed information rate. That's called your access rate, the maximum possible speed you could get out of it, but you shouldn't expect the access rate. Frame relay encapsulation is a little bit different, so it's not HDLC or PPP, it's its own type of encapsulation. And there's really two methods that we can do with it. Number one is the Cisco proprietary method, and that's going to be the default in any Cisco environment. And the second one being IETF. It's a little bit more open. If we're going to work with different vendors, we'll be using IETF. It really doesn't matter at the end of the day, as long as it's the same on both ends. Frame relay is really based around a concept called virtual circuits. Through a virtual circuit, we're able to link thousands of devices together through a provider's quote-unquote cloud. The provider makes the logical mappings between our different interfaces. Basically what it looks like at the end of the day is our two routers think they have a one solid physical connection between each other. They don't see all of the middleman stuff happening at the ISP level. Within there's two types of virtual circuits. There's a permanent virtual circuit, which is always on. It's a static mapping made by your ISP and your telco. As long as you pay your bill, they're going to keep that mapping available for you. The switched virtual circuit's like a phone call. So when your routers need to communicate with each other, the circuit's going to come up, and then when they're done communicating, that circuit goes down, gets freed up, and it goes away. Like I said, this is all hinged on these DLCI or DELCI numbers. Basically, it's something that you're going to get from your ISP. You assign it into your frame relay configuration, and then anything leaving your router going out to that ISP network will get tagged with that traffic. Your ISP will be able to look at that tag, and then from there, make the determination on where it needs to go. You can see these DELCI numbers through something called inverse ARP, where ARP is just a mapping of MAC addresses to IP addresses. Inverse ARP is a mapping of IP addresses to DELCI numbers. So it's going to be important for us to have those. Beyond that, we have a little bit more to talk about the frame relay. We have what's called a local management interface, or an LMI. This is something that's used by frame relay to make sure that the tunnel is up, The virtual circuit's good. We're uniquely addressed throughout that in our DLCI numbers. It handles multicasts, all sorts of different things. And just like anything else, there's different formats for that. Cisco has their own. There's an ANSI standard that's open. The Q933A is another standard. Really doesn't matter, again, just what is your telco using. You just make sure that you match that. So let's actually go set up Frame Relay. So if you go over to Packet Tracer, I've got my two routers configured with IP addresses in the 172.16.10.0 network. These are configured on the serial 000 interfaces. Now to simulate this properly, we're going to pull up a WAN connection here. So if we go down to the bottom, hit WAN emulation, grab the cloud-pt, this is going to represent my ISP, and we're going to use this to set up our Frame Relay. Now go ahead and open up your cloud, go over to config, and we're going to set up Frame Relay just like an ISP might. So we're going to start out with our serial 0 interface. The ISP is going to assign a DLCI number to that interface. I'm going to choose 102, and this can be any arbitrary number. The reason I'm choosing 102 is just for the sake of simplicity. So if you want to think about it like we're connecting from router 1 to router 2, that's how I came up with the 102 here. We'll name it R1 to R2, and I'm going to change my LMI type just to show you that it does work with different stuff. So from Cisco, we're going to change it to ANSI. So next thing we need to do is we'll just hit add, and we should have this LMI connection set up here. So let me get this back up. Seem to have lost my mouse, which doesn't help. There we go. So the joys of virtual machines sometimes. But in any case, we'll add this mapping and we should be good. So let's talk about our serial 1 interface. That's going to be coming out of this side of the cloud, connecting over to router 2. So we'll do the same thing here. I'm going to choose DLCI number 201, just for my ease of thinking. This is from router 2 to router 1. We'll name it R2-R1, change it to ANSI, hit add. So we've made these DLCI numbers. So router 1 will need to configure itself with 102. Router 2 needs to configure itself with 201. Now where this gets really cool is at the ISP level, they make these logical mappings for you. So what I'm going to say is from serial 0, if traffic is coming in, it's destined for router 2, I need to map that to serial 1, which is router 2's connection to router 1. We'll add that mapping in, and we can go configure Frame Relay in our network here. Let's cable this up. So I'm going to choose my cables. Serial DCE, that's going to start out on our cloud, since they're going to tell us the frequency and the bit rate we need to be communicating on. Serial 0 to serial 0. Same thing here, we're going to go serial 1 to serial 0. So the cabling here is at least done on this end. What we're going to do is jump into our routers here. So starting out with router 1, and we can get router 2 up here as well. So we can just configure these both at the same time. So clear the screen off so we have a clean slate to start from here. And I'm already in my serial 000 interface. What I need to do, so the interface has an IP address, it's not shut down, is set the encapsulation. Pardon me, so encapsulation Frame Relay. If I just hit enter, it's going to use Cisco's encapsulation. If I type in IETF, of course, we'll use the open standard. I'm just going to leave it as Cisco for right now, so encapsulation Frame-Relay. We'll do the same thing over here. Encapsulation Frame Relay. Next thing we need to do is set our DELC numbers. So this will be Frame Relay interface DELC. This was number 102. And over here we do Frame Relay interface DELC 201. And those numbers again were just assigned to us by the ISP, so it really doesn't matter what we would have picked there. I also need to set the LMI type, and remember LMI is used for determining the virtual circuit status, some things like that. So we said we're going to use ANSI, so I'll do a Frame Relay LMI type ANSI. Same thing over here. frame relay, LMI type, ANSI. Now what we should be able to do is if I back out of both of these, I should be able to ping between my two routers. Ping 172.16.10.2. This may drop a couple while that frame relay circuit's established, but generally speaking it should go fairly quickly. So we failed there, but not a problem. Let's just check a couple things. Fast forward time just to make sure it's had enough time to synchronize. And if we try to ping it again, okay, so still nothing there. So, not a problem. We can do a little bit of troubleshooting on this. Let's do show interfaces, serial 000, and just see what we have. We have the encapsulation at frame relay. Our LMIs have come up. But for some reason, it looks like my DELC number got set back to 0. Let's go reconfigure those here. Let's do config T. Interface serial 000. Frame relay interface DELC 102. So maybe when we switched to ANSI, that wiped that out. Let's try it on router 2. So config T, serial 000, frame relay interface DELC 201. So let's give that a shot. Fast forward time a little bit, and then see, hopefully we are able to ping now. And still nothing. So let's take a look at our configuration. We'll just make sure we got these the same on both ends. So just a little bit of the troubleshooting process here. Suppose isn't a bad thing. And we'll do a show run. Just make sure we got this the same on both. So let's look at our interfaces here. And I see the problem. So I had this left over from PPP, wrong IP address, simple mistake. We'll just go fix that and then we should be good. Now let's give it a shot. Okay, so still nothing there. Go back to our show run. And let's take another look here. So 10.1, they're both on the same subnet, both using frame relay, have their DELC numbers set. LMI types are ANSI, so let's do this. Double check our cloud configuration, make sure that looks good. So frame relay we have from serial 0 is mapped to serial 1. Serial 0 is expecting 102 for its DELC number, which is in ANSI. Serial 1 is expecting 201 in ANSI as well. So let's give it one more go here. There we go. So I was fairly certain after the IP address we should be good. It just took a little bit more time than expected to get that virtual circuit set up. Nonetheless, our next steps would have been going into the debugging, so we could have done a debug, frame relay, debugged the LMI, which helps us establish that tunnel and figure out where the problems are. But all in all, it's working here at the end of it. So that's basic frame relay. What we'll look at next is doing frame relay with sub-interfaces, which is where we really start to see the benefits